Okay, so today we're going to finish up section 6.1. We'll do some more law of signs. We'll talk about the ambiguous case and how to solve triangles when there's two possibilities. Okay, so to start with, let's just review finding how many triangles. All right, so you have your case 1 and your case 2 from yesterday's notes, so make sure you have those where you can see them. So for this first problem, we're given two sides and an angle, which means that it could be ambiguous. They didn't give us a matching pair or enough information to come up with a matching pair. So we have to look at the angle. The first thought is that the angle is less than 90. So that is case 1. So then we have to compare side A to side B. So A is less than B in this case because 5 is less than 7. So that means that we're going to have to figure out the height of the triangle. So we have to figure out B sine A and compare to that. So again, side A is 5. If we do B sine A, we're going to do 7 times the sine of 35 and get 4.02. So that is going to be a greater than. A is greater than B sine A, which means we have two triangles. All right, so next you have a 54-degree angle. Again, only one angle is given to you. You have, I said something a minute ago about not having a matching pair. That was absolutely not necessary to say, sorry. Just the fact that you only have one angle and two sides makes it ambiguous where you have to decide how many triangles you have. All right, so number 2, your angle, the one angle that you're given, is less than 90. So again, that's case 1. So we look at side A compared to side B, and again, we get less than because 9 is less than 12. So we have to compare side A to the height of the triangle, so B sine A. So again, side A is 9. If we do 12 sine of 54, I get 9.7. And we have a less than. 9 is less than 9.7, which means that that leg is just going to dangle. There are 0 triangles. All right, number 3, they give you two angles, which is an automatic. We have one triangle. If there are two angles, then you have one triangle always. All right, number 4, you only have one angle. So when we take our angle and we compare it to 90, our angle is greater than 90. That means we're looking at case 2. So for case 2, we just have to compare side A to side B. We see that A is less than B. 3.4 is less than 4.3. And when A is less than B, for an obtuse angle, we have no triangle. All right, we're going to keep practicing that because for each one of these questions that we're going to do, you're going to have to know how many triangles you're looking at before you know how to solve. All right, so for number 5, you're only given one angle. So you have to, first of all, think to yourself, this is ambiguous because it's one angle and two sides with a matching pair. So if it was an angle and two sides, but it worked out to be like side, angle, side, then that would not be ambiguous. But that would be a law of cosines problem because you don't have a matching pair. So as long as we have one angle and the side opposite it, we're going to be ambiguous. So we are going to have to look at our angle. We have an obtuse angle. So we're looking at case 2. We compare A to B. We see that A is greater than B. So that means that we have one triangle. So we can solve like normal. We can say side A is 15, angle A is 113, side B is 8, angle B we do not know, side C we do not know, angle C we do not know. All right, so when it comes to solving when you only have one angle, then it's obvious when you write things like this that when you set up your first proportion that you're going to use this information. So we know we're going to say 15 over sine of 113 is equal to 8 over sine of b. All right, so we still have cross multiply and divide. So we're going to have sine b is equal to 8 times sine of 113, over 15. All right, so if we put that in our calculator, we're going to get the sine of angle B, and what I really want to know is what is angle B. So remember, to find angles, we just do inverse sine. So in our calculator, we'll do inverse sine of 8 times the sine of 113 over 15. So in your calculator, what is that going to look like? It's going to be second sine, and then 8 sine 113, close parentheses, divide by 15, and we get 29.4. We're going to go ahead and just round to the tenths today. Remember to make sure you pay attention to your directions. We don't have directions that say one way or the other, so I'm just going to go to the tenths. All right, so we get 29.4 degrees. So now that we know two angles, we can find the third angle by just subtracting. So we do 180 minus 29.4 minus 113. We will get angle C. And I got 37.6. All right, and then from there, I always like to go back to what they gave me so I have less opportunity for mistakes to be in the work. So we're going to say 15 over sine of 113 is equal to C over sine of 37.6. So here we're looking for a side, so we're not going to use an inverse. We can just say side C is equal to 15 sine 37.6 divided by sine of 113. All right, so 15 sine 37.6 divide sine of 113. All right, so I'll put that on my calculator, and I come up with 9.9. So a good way to make sure that you're on the right track is that your biggest angle should go with your biggest side, your smallest angle should go with your smallest side. So as long as you have that going on, you should be in pretty good shape. All right, so let's try another example. All right, so for this one, we have an acute angle. So we're looking at case 1. We're going to compare A to B, and we see that A is less than B, which means we're going to need to know the height of the triangle. We want to compare A to B sine A. All right, so A is 12, B sine A, so 23 sine of 44 gives me 15.98, so we get less than. And if A is less than the height of the triangle, then remember it's just a little dangly leg. So we say no triangle, and we're done. All right, number 7. Again, you have an acute angle, so we're looking at case 1. We compare A to B. A is less than B, which means we need to know the height of the triangle. So we're going to compare 42 to B sine A. So B sine A means we're going to do 60 times the sine of 40, which gives me 38.6. All right, so in this case we have greater than. A is more than the height of the triangle, but it's less than side B, which gives us that option of, we know this angle, we know this side is more than the height, so it can hit over here or it can hit over here. Okay, so that's kind of what we're looking at. So for this to make sense, we have two different triangles going on. All right, so we're going to start out and solve everything like normal. Okay, so we have two triangles. So for triangle 1, everything is normal. So you do A is 42, B is 60, C I don't know. Angle A is 40, angle B I don't know, angle C I don't know. Alright, so we just did this a minute ago, so if you want to pause and see if you can solve this triangle using number 5 as a guide, that would be a good plan. Alright, so we can set up that 42 over sine of 40 is equal to 60 over sine of B. So we know B is equal to inverse sine of cross multiply divide. Alright, so we get sine B is equal to 60 times sine 40 divided by 42. So to get angle B, we do inverse sine. So from my calculator, I'm going to see if I can set it all here for you. I'm going to do inverse sine of 60 sine 40 divided by 42, and I get 66.7. Alright, so to find angle C, I can do 180 minus 40 minus 66.7. And I get 73.3. And then to find side C, I can set up 42 over sine 40 equals C over sine of 73.3. So C is 42 times the sine of 73.3 divided by the sine of 40. And we get 62.6. There's a glare on the calculator, so if I say something wrong, I apologize. I also apologize that you can see half what I just wrote. Alright, so we get 62.6. That's not in degrees, sorry, that's what's happening. I wrote it here too. What a good call. Okay, so that is triangle 1. Alright, so triangle 2. For triangle 2, we know the same information. We know that side A is 42. We know that angle A is 40. We know that side B is 60. We're going to have to figure out angle B, side C, and angle C. Alright, so when you do this the first time, you see how B is an acute angle? So you're finding this outside triangle. You're saying that if I take this leg and I swing it out here, I found this triangle. So triangle 1 is the normal looking triangle. Triangle 2 is going to be the triangle where you swing it back in and you're sitting right here. So you have this obtuse angle right there. Alright, so if we look at this triangle that's created here, this is side B, no, A, I'm sorry. This is side B. This is side A, and this is also side A because it depends on where I swing it. So if we look at this little triangle that we've created real fast, if these are the same, then we know these are the same. So we figured out that angle B, regular B, was 66.7. Well, this angle right here, which we know as B prime, this angle right here, is going to be forming a line with angle B. Because this is angle B, so this would be the same as angle B. So B plus B prime always add up to 180. So moral of the story is all of these guys get a prime because we just need a way to distinguish them. So we put that little apostrophe, which means prime. So to get B prime, you always do 180 minus the regular B. So if I do 180 minus 66.7, that gives me 113.3. So your B prime, number 1, will always be obtuse, and you can always get it by subtracting the regular B from 180. All right, so now that we know B prime, we can find C prime by doing 180 minus 40 minus 113.3. Fingers will not cooperate. I cannot type the right thing in the calculator. 180 minus 40 minus 113.3. I get 26.7. All right, so then you're going to use your law of sines. My brain, sorry, I don't know what I just wrote. Use your law of sines. So we'll set up 42 over sine 40 equals C prime over sine of 26.6. So we use our law of sines to find C prime. So cross multiply and divide. So C prime is what I get when I type that in my calculator. And I got 29.4. All right. So just to make sure that you're understanding what happened here, I'm going to go back and highlight some stuff. So triangle 1 from this picture is what happens if I have my side A swing out wide and I have an acute triangle. For triangle 2, what's happening is I'm having side A swing in and it forms an obtuse triangle. Alright, so let's try another example. Alright, for this next example, we have 2 angles. So if I'm given 2 angles, it's not ambiguous. I automatically know that 2 angles means 1 triangle. So this is just like yesterday's notes. So we're going to set up what it is we know versus what it is we do not know. And we're going to go from there. So when they give us 2 angles, finding the other angle is easy. There's no inverse needed. You just do 180 minus the 2 angles that you know, because triangles add up to 180 degrees. So we'll do 180 minus 102.4 minus 16.7. I get 60.9. Then we just do law of sines. I don't know why I keep writing an A. So we'll do 21 over sine of 102.4 is equal to B over sine of 60.9. So B will be equal to 21 sine of 60.9 over sine of 102. Now remember that your calculator has to be in degrees, so if you're having trouble, make sure that your calculator is set in degrees. Also remember that if you don't have a graphing calculator, there are graphing calculator apps, but your regular phone calculator, if you'll just turn your phone sideways, will have the sine and cosine buttons. All right, I was talking while I typed that in. Let me double check that everything's good. Yeah, I think I agree with that. All right, so then we can set up the law of sines again to find side C. So we'll use our A over sine A. This time we'll equal it to C over sine C. And so we'll get 21 sine of 16.7 over sine of 102.4. So putting that in our calculator, we will get 6.2. Alright, so number 9. Number 9 looks like it's going to be harder, so we're using a calculator, so it's really not. But you have the degrees and minutes, but those are just buttons in your calculator, but also 30 is half of a full degree, like 30 minutes is half a degree, so if you want to call that 15.5, you could do that also. Alright, so to start with, you're only given one angle, so you have to look at your angle, and your angle is acute, so it's case 1. Alright, so we don't have things given to us the way that we want them to be. Alright, so if we're just making the decision how many triangles, then we can relabel things, like I told you yesterday. But if I'm trying to solve a triangle, I kind of have to leave things called what they're supposed to be. So we have an angle that's acute, so we're case 1. So we want to compare the two sides, but the side opposite the angle is the one that we have to use first. Normally we would do A compared to B, but since they gave us angle B, we're going to have to do B compared to A this time. So B is greater than A. So we're looking at case 1, and we have the side opposite greater than the other side. That means that there is only one triangle, which is good news. We only have to work the problem one time. So we know that side A is 4.5. We do not know angle A. We know side B is 6.8, and angle B is 15 degrees, 30 minutes. We do not know side C, and we do not know angle C. Alright, so I was looking at it, and I think this is where I need to start. So we're going to say 6.8 over sine of 15 degrees, 30 minutes is going to equal 4.5 over sine A. So I'm trying to find an angle, so I start with inverse sine of, and then cross multiply, divide. So 4.5 sine of 15 degrees, 30 minutes over 6.8. Alright, so in my calculator, that is going to look like second sine 4.5 sine, 15, if you go here, but do second app so that you get the angle menu, you can choose the angle symbol, and then 30, and go back and choose the minute symbol, then divide by 6.8, and we got 10.2. These are some tiny little angles. Alright, so 10.2. Well, they gave us minutes and degrees, so we should probably do the same thing. So if you'll remember, you can just go second angle, and you can change it to degrees, minutes, seconds. So tell it you want to do number 4, and it'll tell you that it's 10 degrees, 11 minutes, and we'll call that 11 seconds. Alright, so now we can, or if you want to just go to the nearest minute, because that's what they gave us on B, that would be okay also. I think I'll do that. We'll leave the seconds off. Alright, so now to find angle C, we're going to do 180 minus 10 degrees, 11 minutes, minus 15 degrees, 30 minutes. And I think just because it's less to put in the calculator, I'm going to go ahead and combine these and say that I'm really subtracting 25 degrees and 41 minutes. So I'll do 180 minus 25 degrees, 41 minutes, which gives me 154 point yada yada. But if I change it to degrees, minutes, seconds, it's 154 and 19 minutes. Alright, so then to find that last side, we can say 4.5 over sine of 10 degrees, 11 minutes. Nope, why don't I do that? I mean, you could do that, but let's use what they gave us. So 6.8 over sine of 15 degrees, 30 minutes is equal to C over sine of 154, 19. So C is equal to 6.8 times the sine of 154 degrees, 19 minutes, all divided by sine of 15 degrees, 30 minutes. Okay, so in my calculator, we want 6.8 sine 154 19 divided by sine of 15 30. And we get 11.0. Okay, so number 10, I want you to try it on your own. So pause the video, work it, and then unpause and see how you did. All right, so on number 10, we have case 1 because we have an acute angle. If you compare A to B, you have that 8 is less than 9. So then you have to look at the height of the triangle and compare side A to that. So if we do 9 times the sine of 60, we get a height of our triangle of B sine A of 7.8. And 8 is more than that, which tells us that we have 2 triangles. So we're going to have to figure out triangle 1 and triangle 2. Alright, so triangle 1, remember that you just set everything up normal. And find it, all of your info. So we can say 8 over sine 60 is equal to 9 over sine B. So B would be 9, note it'd be inverse sine of 9 sine 60 over 8. So angle B, I lost my calculator, is second sine of 9 sine 60 divided by 8, which gives me 76.97, so we'll call it 77.0. Alright, so to find C, we can do 180 minus 60 minus 77, and we get 43. And then to find side C, we can do 8 over sine 60 is equal to C over sine of 43. So C is 8 sine 43 divided by sine 60. Which gives me 6.3. Alright, so now that you have done triangle 1, triangle 2 has the same given information. But we have a new angle B, a new side C, and a new angle C. Alright, so remember that the first thing we do is find angle B. And that's always going to be B prime is equal to 180 minus angle B that we found a minute ago. So regular angle B was 77. So we do 180 minus 77, we get 103. So then to find C prime, we can do 180 minus 60 minus 103. So that gives me a pretty small angle, 17. And then to find side C prime, we just set up our law of sines. So C prime will be 8 times the sine of 17 degrees over the sine of 60 degrees. And I get 2.7. All right, if you have questions, please let me know.